Today we're going to be looking at applying the trig functions to the unit circle. So yesterday what we did is we built the unit circle and we looked at the different fractions of pi that show up. So we looked at halves, fourths, thirds, sixths, and then each of our axes. So today we're going to kind of break it down and view each of them separately. So here on the first page of your notes, you're probably going to have to write down these radian measures yourself. They didn't copy that great on the notes. But what I want to look at here is notice the ordered pairs are already filled in. And these ordered pairs, if we look right here in the first quadrant, we've got 1/2 and radical 3/2. And so remember, the way that translates is that the length across the x-axis here is 1/2. And then up in the y direction, that's radical 3/2. Okay? The hypotenuse is 1 all the time because in the unit circle, the radius is 1. So let's say I wanted to find out, for instance, our trig functions. So we'll say sine pi over 3. Let me get rid of that theta. So sine pi over 3 cosine pi over 3 and tangent pi over 3. Okay, so that puts us right here for pi over 3. That's this triangle right here. And sine is opposite over hypotenuse. So that would be the opposite side, which is radical 3/2. And the hypotenuse, which is always 1. So obviously radical 3/2 over 1 just simplifies to be radical 3/2. So now let's keep going. We'll take care of cosine. So cosine would be adjacent over hypotenuse. So the adjacent side is 1/2. Hypotenuse is still 1. 1/2 divided by 1 is just going to be 1/2. Tangent would be opposite over adjacent. So this one is going to look a little bit ugly here. So the opposite side we said is radical 3/2 over the adjacent side, which is 1/2. I can't leave it like that. We are going to have to multiply by the reciprocal of the denominator so that it looks a little bit nicer. So this is going to give me 2 times radical 3 over 2 times 1, which is just 2. So then we're going to have the 2's cancel, and tan would be radical 3. Don't focus too much, you guys, on the manipulation I did here to get down to that radical 3. Really just concentrate on where I'm pulling the numbers, being like the opposite and the adjacent. Okay. So now I've got these 3 over here. There is going to be a pattern that you should end up picking up on. I'll show it to you over here on this triangle. So 2 pi over 3 would be that big angle right here that I just traced, okay? So then in here is our reference angle, which is, it's going to be another 2 pi over 3, or sorry, pi over 3. However, as I write these though, I'm going to use the reference angle that they give me. We'll talk more about that when we're together in class. So sine of 2 pi over 3, cosine of 2 pi over 3, and tangent of 2 pi over 3. So similarly then down here in the third quadrant, these will all be 4 pi over 3s. All right, so now let's give this one a try here. So I'm going to go ahead and just label the sides. Now I can see them in the ordered pairs. So the x coordinate is -1/2. So that means this distance in the x direction is -1/2. The y coordinate's radical 3/2. And so the y component has a length of radical 3/2. As I find sine, cosine, and tangent. Sine is going to be opposite. So that's the radical 3 over 2. And then the hypotenuse, remember, is still 1. So radical 3 over 2 all over 1 is still just radical 3 over 2. Okay, then for cosine. Cosine would be the adjacent over the hypotenuse, which will just be negative 1/2. And then tangent will be radical 3 over 2 over negative 1/2. And then here's the thing, you guys, I don't really want to go through that math all over again. And so when I say that math, what I'm talking about all of this work over here. So instead of doing that, I'm just going to say, I notice it's the same two numbers. I just have one of them being negative. So if I were to do the same stuff, I would just end up with a negative radical 3 instead of a positive radical 3. Okay, so then down here on 4 pi over 3 in the third quadrant. So same thing, we're taking care of like our opposite adjacent hypotenuse. So now they're both negative. Both the x and the y components are negative. So sine of 4 pi over 3 is going to be negative radical 3 over 2. Cosine is going to be negative 1/2. And tangent is going to be radical 3. So you'll notice I said less and I showed less work as I went through that one. I want you to be able to pick up on the fact that the trig functions can be easily identified by looking at the ordered pairs. Okay, so check this out. Let's look at sine. So sine pi over 3 was radical 3 over 2. What you need to connect is that that is actually the same as the y-coordinate. If I jump to the second quadrant, sine of 2 pi over 3 was radical 3 over 2. And what do you know? Again, that's the same as the y-coordinate. And down here for the third quadrant, sine was negative radical 3 over 2. And that is, in fact, the y-coordinate once again. So then in the fourth quadrant, let's see if we can use this shortcut. Sine of 5 pi over 3 is just going to be the y-coordinate, which would be negative radical 3 over 2. Okay, let's see what this pattern is for cosine. So for cosine, we got 1/2. Well, that's the x-coordinate in that quadrant. Over here in the second quadrant, cosine was negative 1/2, which is again the x-coordinate. In the third, negative 1/2 again, the x-coordinate again. So cosine of an angle is always going to be the x-coordinate. So in this problem, cosine of 5 pi over 3 will end up being 1/2. And then for tangent, so tangent it still has to deal with y and x. It's just a little bit harder to identify as quickly. So for this one, I'm going to come over here to the first quadrant, and I'm looking right here at opposite over adjacent. So it was radical 3 over 2 over 1/2. So that's y over x. Let's jump to the second quadrant and see if it's still y over x. So here's y. That matches up. The x-coordinate was negative 1/2, so y over x works. And then on the third quadrant, I didn't show the work, so it's a little harder to see. So then where we're at, it's just going to be y divided by x. So radical 3 over 2 divided by 1/2. And then same thing, I'd have to go through, take care of that denominator, but I already know, sorry, I left a negative off right there. I already know it's going to simplify down to radical 3, right? But we do have a negative on the top. So here what you have is kind of all of the work that shows us how we can find the trig functions. But what I ended with in red is going to be the ticket to finding them quickly. So let's move to the next one. Here on the next one, we've got the sixth, okay? And I want to be able to use the shortcuts. So as I go through this, sine of the angle, I'm going to look at the y. Cosine of the angle, we're looking at x. And tangent is going to be y over x. Okay, so here in the first quadrant, sine of pi over 6 is going to be 1/2. Again, looking at the y. Cosine of pi over 6, pull the x, radical 3 over 2. Tangent of pi over 6 is going to be y, so 1/2, divided by x, radical 3 over 2. Okay, and I got to do this work here one time so I can at least make it look a little nicer. So here, as I multiply through, it would be 1 times 2, which would just be 2, over, and then 2 times radical 3 would be 2 radical 3. They won't want it to stay like this, so I would rationalize by multiplying by radical 3. And so then this would give us 2 radical 3 over 2 radical 9. 2's cancel. Square root of 9 is just 3. And so tangent is going to be radical 3 over 3. As I mentioned before, that's kind of a lot of work, but what's nice is now I know that tangent for all of the other ones is going to be radical 3 over 3. I just will have to adjust the sign for that quadrant. So over here to the second. Sine of 5 pi over 6, I'm looking at the y-coordinate, would be 1/2. Cosine would be negative radical 3 over 2. And then tangent, like I said, I know it's going to be radical 3 over 3, but when I divided y by x, it would have been a positive y divided by a negative x, and a positive divided by a negative is still negative. So that's the only thing to kind of consider when you get to tangent. In the third quadrant, sine of 7 pi over 6 would be negative 1/2. Cosine would be negative radical 3 over 2. And then tangent would be positive radical 3 over 3. And then finishing on 11 pi over 6. So sine will be negative 1/2. Cosine will be positive radical 3 over 2. Tangent will be negative radical 3 over 3. And then we got the fourth. So here for the fourth, you guys, same thing, this is going to go much, much faster. I won't even fill out all of the other three quadrants here. So rules are all still the same. So sine of pi over 4 is the y-coordinate. Cosine is the x-coordinate. And tangent would be y over x. So in this case, radical 2 over 2 divided by itself would simplify down to 1. So that one right there for sure is a lot nicer. So then as we move around to the other quadrants, sine over here is going to be that y-coordinate. Cosine is the x-coordinate. And then tangent would be negative 1 instead of positive 1. Here in the third, cosine is first. and sine is second. And then tangent would be back to positive 1. Fourth quadrant, cosine's first, sine is second. Tangent would be back to negative 1. So now what we could say is, in summary, cosine of any angle is going to be the x-coordinate. Sine of an angle is going to be the y-coordinate. Tangent of the angle is going to be y over x. And we're not really doing much with it, but you can make sense then of the reciprocal functions. So secant would be 1 over x. Cosecant would be 1 over y. And cotangent would be x over y. So really just worry about the main 3 trig functions there. And then the last thing I want to do with you here is just kind of review the the labeling of the unit circle. So I'm just going to fill in here counting. First, I'm going to do just the stars. So we got 0 or 2 pi. Then we would have pi over 2, pi, and 3 pi over 2. I'll take care then of the squares. But when I do the squares, you guys, we also count the stars. So it would be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then we would end on 8 pi over 4. Okay? Anything that I had already written down in black, like for the stars, I would keep that. So I probably wouldn't actually write the yellow that you see there for those ones. All right, now we take care of the triangles, circles, and stars all together. So these will be your sixths and your thirds. So here we have 1 pi over 6, 2 pi over 6, which reduces, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7, 8, 9, 10, 11, 12. And then last thing to do is to fill in these ordered pairs. So when we fill in the ordered pairs, remember the stars will be easiest. So 1, 0, 0, 1, negative 1, 0, 0, negative 1. Then when we get to our sixths, our fourths, and our thirds. So the fourths are easy. On the fourths, the terminal points match. Those are both radical 2's over 2's. So then when you take care of the fourths in the other quadrants, you just have to account for how the signs might change. So in the second quadrant, every x-coordinate is going to have to be negative. Every y-coordinate would still be positive. In the third quadrant, they're both negative, and in the fourth quadrant, only y is negative. All right, now for the sixths and the thirds. So sixths and the thirds, we should eventually know that that's where we get the 1/2 or the radical 3 over 2. So I do like to kind of draw here just to remind myself. So I'm just drawing out to the triangle, dropping a leg down, okay? And the reason I like this is because I can see now that out of the two legs, x is the longer side, which means it's the bigger number. Radical 3 over 2 is the bigger number when compared to a half. So that's going to be all of the sixth. All of the thirds are going to be flip-flopped. So on the thirds, x is short, so 1/2 is first, and radical 3 over 2 is second. And again, reflecting them to their other quadrants and taking care of the signs as we go. And so now that the unit circle is completely filled out, you guys, if I were to ask for cosine of any of these things, you just need to tell me the x coordinate. Sine would be just the y coordinate. Tangent would be y over x, and tangent's a little bit harder until you've practiced it enough that you'll start to memorize those radical threes.